Literal equations and formulas. This has to do with mostly how you're going to think of this is formulas. Ones that you're familiar with are ones like area of a triangle is 1/2 base times height. And we're going to see about how to manipulate those formulas where you are trying to figure out a certain part of it. So the learning target is I will rewrite and use literal equations and formulas. So first, what is a literal equation? It is an equation, so that means we have an equal sign in there, that involves 2 or more variables. So it is not something like x equals 5. That's just telling you the value of x. A literal equation is going to have 2 different variables, such as area equals length times width. So A equals LW. And oftentimes it is a formula, so that means that those variables are representing specific quantities. Here are some ones that you should be familiar with. Go ahead and copy each of these down. You wouldn't necessarily have to copy down the definition of the variables, this portion right here, because I think you know, or at least you should know, that a capital P is perimeter, L is length, W is width, capital A is area, lowercase b is base, and so forth. So the formulas that you should be familiar with: perimeter of a rectangle, that's the distance around that rectangle. Circumference, that's the distance around the circle, it's like perimeter of a circle. Area of a rectangle, that's probably the first formula that you were ever introduced to. Area of a triangle, area of a circle. The distance formula, you've probably heard that one a lot in science, as you may have heard the temperature formula in science, where you can convert between Celsius and Fahrenheit. So when you see this phrase, solve for, let's say, x, or solve for length, or solve for y, what that means is get whatever variable that was. So if it said solve for y, that means get y on one side of the equation by itself. Remember, when we're saying literal equations, we have 2 or more variables. And so you are confident in your ability to isolate the variable. But the question is, there might be more than one variable, so which variable do you isolate? And it's going to be whichever one it is that you're solving for. So let's take this equation here. Y plus 2x equals 5. It's a literal equation because I have an x and I have a y, 2 different variables. And my directions are saying to solve for y. So that means I need to get y by itself. So that means we're going to undo what's happening to y, which is it's having 2x added to it. So I undo addition with subtraction. So you can see where I'm subtracting 2x on both sides. And then once you subtract 2x on both sides, it cancels out right here. That 2x and negative 2x cancel, and you're left with y equals negative 2x plus 5. Notice I did not subtract 5 minus 2. Those are different terms. So I list them together there. I do not combine them. So my answer is y equals negative 2x plus 5. That's not the solution, because I don't know the value of y, but what I've done is I followed the directions. I have solved for y. I have y on a side by itself. So here is some practice with it already. We're going to practice. We are going to solve the equation for y, and then we're going to find the value of y for each value of x. So in blue, that's what we're doing first, solving the equation for y. Then in red, this portion here goes with the second part of directions. Find the value of y for each x value. So since I'm solving for y, I'm wanting to get y on a side by itself. So I'm going to undo what's happening to that. It's having 7x added to it, and it's being multiplied by 2. I'm going to undo adding first. So I'm going to subtract 7x on both sides. So those cancel there. 2y comes down, and that's going to equal negative 7x plus 4. I did not combine negative 7 and 4 because they are not like terms. Now I can divide both sides by 2 because I want to undo that multiplying by 2. And so I have y equals negative 7 over 2x plus 4 divided by 2 is 2. That goes back to when we learned about distributive property, and we were distributing that division. That's like multiplying each term by 1/2. So that's half of the problem. I have solved for y. Now that I've done that, I'm going to find the value of y. I'm going to evaluate y for each of those x values. So When x equals 5, I substitute that in. Y equals negative 7 over 2 times 5 plus 2. So we're going to multiply first. To multiply this here, I can think of that as 5 over 1, or I like to just go ahead and multiply 7 times 5 is 35, and then I have 35 over 2. That does not simplify, so it's 35 over 2, and it's negative because it's a negative 7 over 2 times positive 5. So I have negative, whoopsie daisy. Let's erase that there. Pick my pen back up. Okay. Negative 35 over 2 plus 2. To add those fractions, I'm going to think of that whole number 2 as 4 over 2, so I have a common denominator. Negative 35 plus 4 is negative 31 over 2. So there's another part of it. Now I'm going to evaluate that for 10. So if x equals 10, let's substitute that in. Y equals negative 7 over 2 times 10 plus 2. So multiply that. Negative 70 would be on top over 2, which simplifies to negative 35 plus 2. Or I could have thought of that as 10 over 1, cross-simplified. Either way, you're going to get negative 35. And then negative 35 plus 2 is negative 33. So that's for the second value. And the third value we're doing is 15. Do that over here. So for x equals 15, let's substitute that in. Y equals negative 7 over 2 times 15 plus 2. So think of that as 15 over 1. Negative 7 times 15. So to do that in my head, I know 7 times 10 is 70. 7 times 5 is 35. 70 plus 35 is 105. So I'm going to have negative 105 over 2. And like I saw up on this other example, to add that whole number of 2, I'm going to go ahead and give that a common denominator and rewrite that as 4 plus 2. I'm anticipating adding those. Then when I add my numerators, negative 105 plus 4 is negative 101 over 2. And there's that answer. So I've completed all three parts. First, I wrote it with y on a side by itself. I solved for y, and then I found the value of y for each value of x. So when x is 5, y is negative 31 over 2. When x is 10, y is negative 33. When x is 15, it's negative 101 over 2. Okay, so let's try this one. I'm solving for x, so this part up here. I have this adding 2 to undo, but before that I have to get rid of this fraction. So the sum x plus 2 is being divided by y minus 1. So what I can do is I can multiply both sides by y minus 1. That would be like y minus 1 over 1, and those cross simplify to cancel. So x plus 2 is left on the left side. And then I need to distribute that 2 to each term. So I have 2y minus 2. And I need to continue isolating x, so I can undo adding 2 by subtracting 2 on both sides. On this right side, I'm going to put it underneath the constant 2, not the term with the variable. I'm anticipating combining like terms. That cancels. X is left by itself. So I have 2y, nothing happens to 2y, and negative 2 minus 2 is negative 4. So solving for x, I end up with x equals 2y minus 4. Here's another one that it might look like. Solve 2 times the quantity x plus 4 equals 4b for a. So I'm wanting to isolate the a right there. I'm going to rewrite it down here. 2 times x plus a equals 4b. I'm going to undo multiplying by 2 by dividing both sides by 2. That multiplying would come before the parentheses in order of operations. So those cancel. On the left side, I'm left with x plus a equals, and then 4b divided by 2 is 2b. Then I want to get rid of adding a because adding x because I'm solving for a. So I'm going to subtract x on both sides. X minus x cancels. A is on a side by itself. Then I have 2b minus x. Hopefully you're starting to see all that practice of inverse operations and where I ask you to show your work. That really helps when you're doing literal equations, because I can't solve this kind of stuff in my head. I have to follow those steps with inverse operations. So I have A equals 2B minus X.